pretty much on.
Okay, 26 says, write 1/10,000,000th of a millimeter in meters. Okay, how many, gosh, it's tricky. Sometimes they just take the problem and make it a little bit too much. But how do we write 1/10,000,000th? What's this place called after the decimal? Tenths. This is the ones, this is the tenths. What's that?
Thousands. 100,000.
Hundred thousandths, million. That would be 10 millionths. How far did it say go? Did it say 10 millionths? Okay, it said 10 millionths. So what would 1/10,000,000th look like?
All zeros except for
One, yeah. Okay, now here's where they took a reasonable problem and they made it a little too hard. They said this is 1/10,000,000th of a millimeter, but we want to talk
Meters.
meters. So how many millimeters are there in a meter?
No, there's 100 centimeters.
Right, there's 100 centimeters in a
So,
meter.
500.
Hey, Jasmine, sit up.
500?
No. Okay,
I don't think they're really tall.
metric
1,000.
Oh,
uses tens, hundreds, thousands, powers of 10, right? Metric uses powers of 10.
million.
You guys know what a centimeter is?
Don't.
It's, yes, I do.
No.
It's the
No.
inch.
Okay, what are these? Inches. Okay, what are these? It says 1 centimeters.
And are the little things in the way?
Uh,
Down. Okay.
they don't have any millimeters on here. Okay, if I had a ruler, which there are some in the back, there would be teeny tiny little marks between the centimeters. How many millimeters make a centimeter? 10.
10 times.
It'd be, I'm not gonna grab the ruler.
120. 120.
Millimeters are tiny, 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 like the width of your fingernail or something like that. So that's how it takes 10 of them to make a centimeter. So if there's 100 centimeters in a meter,
120.
then there's 1,000 millimeters. You guys remember what millimeters, right? Millennium? Millipede means 1,000, okay? A millennium is 1,000 years. So, anyway, a millimeter is 1,000 of those in a meter. So, a millimeter is 1/1000th of a meter. So we want actually a 1,000th of this.
Times that by.
Times this by 1/1000th. If we times it by 1/1000th, basically the decimal moves back 3 more times. So we need 3 more zeros. 3 more decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the 1.
Yeah, let's go to the restroom.
Yeah. Because we're changing
So
millimeters into meters.
And then you put 1/10,000.
If it's 1/10,000,000th of a meter, then it's going to be a even smaller decimal. Anyway, so the point is you're supposed to change this number into scientific notation. So the decimal should end up right there, right? So it's 1
I think that's 10.
times 10 to the something.
10 to the 10.
Yeah.
Okay, if it's a decimal though, what would the exponent be? Negative.
Yeah.
10 to the 10.
It's 1.
Okay, 27. Light travels at 300 million meters per second. That's pretty fast. How many kilometers does it travel in an hour? Ugh. Gosh darn it. Just give us a normal problem.
Well, isn't there 1,000 meters in a kilometer?
Okay, hold on. We'll do it. It's not as, it's just something we did when we go over exactly. So it's 300 million. Okay, there's millions, thousands, ones. Meters in 1 second. Okay, that's not the answer, that's just what part of the problem. Okay, and they want us to change it to kilometers in an hour.
What did you, is this like cross application? I'm not.
No.
How many seconds are in
How many meters are there in a kilometer?
1,000?
1,000. A meter, this is a yardstick, but it's almost a meter. It's 91 centimeters, so it's a little bit bigger. Anyway, there's 1,000 meters in a kilometer. So, if we divide this by 1,000, so a lot of meters only makes a few kilometers. So if we divide this by 1,000, that'll change it into kilometers. So, you guys know what we get if we did 300,000 divided by 1,000?
300,000.
That's right. Basically, those zeros cancel out, so it's 300,000. That's not quite. We're not quite done yet. And then, how do we change seconds into hours?
Times by 60. You just
Okay. It takes a bunch of seconds to make 1 hour, so 1 second is only one. Oh gosh.
Can we just skip this one?
3,600.
So, it is right. Good job. There's 60 seconds in a minute, 60 minutes in an hour, 60 60s is 3,600. So, 1 second is 1/3600th of an hour. So we divide by 3,600. Which would be like multiplying. So here, don't worry about the other part. I'll just leave that to me, and
You'll just leave that to yourself.
Wait, what?
yeah. Basically, this is how many kilometers an hour light goes. Okay, so let's somebody plug that in your calculator.
It's
108.
108,000,000,000,000.
Yeah. Okay.
What?
All right. How many zeros after the 8?
7.
Can't count 7. Okay.
Next.
Yeah.
10.
Forget that. 1, 2, 3, 4, 5, 6, 7.
Yeah.
I'll check and see if you're right here in a second. Okay,
Hey,
so basically this is the ones, the thousands, the millions, billion. 1 billion, 80 million miles per hour. Let's see if we did that right.
1.0.
Yes, we did. Okay, but this is not the answer. The answer is what's this in scientific notation?
What are you?
The answer, this is the easy part.
1.08.
How do you write this? Just do it yourself. Yeah, how do you write this in scientific notation?
Me.
1.08 times 10 to the 9.
Do you get it?
Yeah.
Okay. Yeah, I'm not gonna I will put numbers on the test and you change them to scientific notation, or there's a number in scientific notation, you turn it to a normal. Like that'll be 2 of the problems on the test, but I won't do 26 and 27 are kind of a bit much. Okay, 28. This is definitely on the test. It is doable, but we haven't done this in like 3 weeks at this point. So you probably might have forgotten.
I really don't even remember doing this.
This is the one I said I couldn't find, Marion.
Oh. No wonder.
Anyways, so 29, I guess. Actually, before we do 28, 29 and that, let's take a jog back in time here.
It's a walk down memory lane.
Okay,
Can we make
What's-
plus 5?
when you have an x squared,
Oh yeah, I
What-
remember.
what is the graph going to look like if we made a picture of it? Yes. Does anybody remember what that was called?
A U.
Parabola. Parabola. It doesn't actually go straight up. It continues to get steeper, but it never gets straight up. Anyways, do you guys remember what normally, like if you do y equals x squared, the vertex is at 0, 0. You guys remembering this? Like that? And we graphed some, and I gave them back to you yesterday. What does this minus 3 and the plus 2 do to the graph?
It
Down.
changes where.
Moves the vertex, moves the whole
Yeah.
graph.
It's like, be like right 3 up 2.
Right 3 up 2. So that's what we're doing.
Oh.
Okay, that's not a problem. This is just an example. This is the whole graph would move right 3 up 2. So it's like if it's on the x, it affects the x motion. This is the x-axis right here. But it does the opposite of what you might guess. If it says minus 3, it actually, instead of moving left 3, it moves right 3. This does exactly what you would guess. If it says plus 2, it actually does move the graph up 2. So the vertex would be at 3, 2, or the graph would move right 3 up 2. You guys remember that stuff? You do remember
Why
it?
it goes right instead of left inside
Took me a
parentheses?
second.
Huh?
Like when you subtract it, why does it go right?
Basically what's happening is it makes everything happen 3 slower, which means that the graph moves 3 to the right. So, I don't know. Yeah, makes it go 3 backwards, kind of, if you think of things from left to right. 29, I guess. Okay, do you guys remember what the x cubed function looked like? It wasn't a parabola, it was like a...
Parabola.
I don't know, there's no name for it, it's just that.
A squiggly.
Okay, what is that plus 7 gonna do the graph? Up 7. So where is that point in the middle gonna be if it moves up 7? 0, 7. So that's the answer to 29. They call that the point of inflection, where it's, whoa boy,
Wait, what was the other?
that was exciting.
What happened?
Do it. Yeah, you didn't even do 28.
I know it's an even, so.
Even Steven.
So all we have to do is just sort it. Great.
So, yeah. Anyway, they don't call it the vertex on 29, they call it the point of inflection.
What is it on 28? Is it 0?
Oh, I remember this. I literally
Okay,
remember this.
29, so maybe you did do it then.
'Cause I-
29 is up 7, so the point of inflection is at 0, 7. That's the point that's up 7. 31, actually 30 and 31 are a little bit easier because it confuses people when there's no parentheses. What would 31 be?
Down 4.
Okay,
6.
31.
Left
Right
four.
6?
Would it be
31.
Would it be 2, -4?
Okay, it's right 2 and down 4, right? So yes, it is 2, -4.
What about
Right
the,
2, down 4.
What about the exponent 3?
The exponent 3 tells you what the shape of the graph would look like. If it has an exponent 3, it'll be that shape.
Okay.
If it has an exponent of 2, it'll be the parabola. But we're not graphing it, so that part doesn't matter. When it's an exponent of 3, that point is this, we call it the point of inflection. When it's an exponent of 2, the point is the vertex. Alright. So it's easy, but we haven't done it in so long. I feel like we might have forgotten it, I'm afraid.
Wait, is 28 gonna have a 0 in it? Like what, as on the point?
Yeah, 28 will have a 0 in it. It's kind of like 29, but the opposite. Okay, 33. same thing, we're just saying instead of where the vertex is at, we're saying how the graph moves. So how does the graph move on 33?
Per the squiggly.
It moves.
Oh, we're supposed to graph these. Moves what?
Up to, and
Right 3 up 2. So that's 33.
that's all we're writing.
Yeah, we'll skip the graphs.
Oh, great.
What about 32 then? You can't really write.
I forgot what I said. Right 3 up 2. Oh, wait, I didn't assign 35 and 36.
Oh, yeah.
So we're going to 37.
You signed 34 though. Yeah.
Yeah, it's an even.
That looks hard.
Oh, is it? Write a function that describes y equals x squared 3 units up and 5 to the right. You can do it. You just saw the words and panicked.
Yeah.
Yeah. Okay, 37. Evaluate. I don't even need to help you guys with this. What does that mean on 37? Plug it in. Plug what in? Negative 2 to the x. X equals negative 2. So it's negative 2 times 3 to the negative 2. Let's try this without a calculator.
Confused by what it's.
Okay, 37. It says evaluate with x equals negative 2. So if I put a negative 2 right there, here's what we always forget. What's 3 to the negative 2? Don't say negative 9. No.
6.
No.
6.
Getting colder.
Negative 9.
I thought somebody would remember.
Wait, what is it? What is it?
Oh yeah, it is. It's
Negative 1
yeah.
Getting closer.
It's 1 9. Oh.
Cheater, I said no calculator.
Oh, really? Oops. Hey, 1 9. It's not 1/3.
Okay, somebody said 1/3. This is 1/3.
I got 5.
Oh.
This is 1 9. So what is negative 2 times 1 9? Negative 2 9. That's it.
Right.
Now on the test, you can use your calculator, but we should.
Wait, how'd you get the coordinates? Oh, you just looked at
37, it just tells you what to plug in. Okay, 39, I am going to make us graph that, so I'll get the graph paper out. We really only need half papers for this, so why don't you guys do some evens while I'm running that up?
I don't know if those graph people.
There you go, Sam. Or you don't really need. Who else doesn't need graph papers? Good, huh?
I do know the graph paper.
Wait, and then also can you tell me how to do X part is easier because I didn't know. How are you supposed to?
Oh, when D is whatever. Oh wait, okay, I got this in.
You know, you just do this
One
times something,
hundred
something,
times
something.
1/2.
Where is it?
That's what I don't think that.
To the what?
I don't know.
Is D 3. D
I've
is
done
3.
25 or
D is 3.
Is it that?
20. Yeah, I know.
No,
Okay.
it's negative.
25 or
Where is it? Because I use that. Like, look, that's squared and then.
Yeah, 25. Yeah, it does. Half of the number is times that. Oh, to the power of 3. Yeah. Times. Alright. What's your next one? 28. Oh. It's 1.
I know it. So I've done it. I've done it.
Oh, shoot. Don't do that.
Mr. Drug?
How many more minutes?
Yeah.
Yeah, that's good.
It's okay. Oh, I mean, I can leave you my own. I would really ride it into the wait, let's try
Because
it.
as soon as sexual ethics, so they really practice early. Most of the kids are public school and they're doing virtual, so.
Do well.
Do you have a swim meet, is that why?
No. Practice.
Yes.
You go full for track?
Yep.
Oh, we just have two.
So it was like bigger than this, I was thinking two, where this is very little here.
How are you supposed to make the cable?
It's still short and we're
You have to make it down.
Wait.
So I want to leave 5 x values, so it'd be like maybe 2 to 2.
You can learn by yourself.
You can use whatever you want.
You have J.
Yeah, you need
Wait,
more.
so you minus, when you minus, do you add? Or maybe multiply?
Like, what are you doing?
Yeah, I still have a
No,
I didn't know that.
this is totally different.
Right.
You don't do anything with exponents. Like, remember when we do like 3x plus 5x, what is that? Okay, not a squared, it's just, so this doesn't change at all. Just, okay, you can only add and subtract like terms though, so you simplify each term. This would be J3, K4. 2, J3, K4. Minus 9, J3, K4.
I never realized how much
Like this, when you multiply the letters together, you add the exponents. So it's 2, J3, K3, minus 9, J3, K4.
We're still friends, but
Because
Maybe.
K,
Like,
I'm sure it's fine.
J3,
I think it's
K4.
like not to answer that phone anymore.
Minus 1,
And I asked Sue and I was like, you're doing it.
and then goes to
And I was like, yeah,
Oh,
she
not
was
fine.
when it needs to call you and I'm like, I can't call your number. I can't call either of you.
They're all the same, which means they're like terms, that means you can add them together. At this point though, you do not change the exponent, it's like 3 of these plus 5 of these. Yeah, you add them together. Yes, you add them together. You don't change the exponents, you just add the numbers in front. They're all J3K4, so your answer is going to be some number of J3K4.
Oh.
Is 39 really shallow?
I don't know how to do
Okay, start with the exponent. This would be multiply. So the x4, y2,
Do something negative.
How'd you get the
Wait.
and then y.
16. Two minus 9 is not negative.
X4 so far.
Yes, I would like that too. I don't even think we do that.
Y squared. Anyways, this is Y what?
Wait, did we do odds or
Yeah.
Why not? What does it mean by leading variable in the
Okay.
numerator?
Means if you get a negative exponent, don't flip it to the bottom. So you multiply these together, so it's just x4, y9 over x3, y2, which means you can still simplify
Because the other two are
into x divided by x, y divided by x, subtract the exponent.
I think,
No, that's your idea.
It's really shallow.
actually, it's actually not that bad.
I could have
You can say that.
Plus, it's always one.
On 39 and 40, maybe I will do 39. I kind of got sidetracked. All right.
Are you done besides?
Okay, now 40 seems correct.
Let's see.
Isn't there that I like?
No, wait, it looks
I like it better. I like that. Daily for kids. Can you barf surfing? Especially
All right. 29 does not tell us what to use on the table, or 39 does not tell us what to use for the table. So I want you guys to use the 5 standard, like x values, -2 to 2. And it says y equals 3/5 to the x. So, you guys know what 3/5 squared is without a calculator? 3/5 times 3/5. Basically, you just do the top squared and the bottom squared. 3 times 3 is 9, and 5 times 5 is 5. But if it's to the -2, you also flip it. So it's 25 over 9. But since we're going to have to graph that, what's 25/9 as an improper, or a mixed, I mean. 9 goes into 25 how many times? 2 with the remainder of 7. So the 2 and 7/9 will help us graph it better than the 25/9. All right, anyway, what does a -1 exponent do? Well, anything to the first is what? Itself. So if you have a negative, though, on the exponent, it flips. So it's just 5/3. Which is also, if I divide, 5 divided by 3, 1. Right, 1 and 2/3. What's anything to the 0 power? What's anything to the first power? Self. What's, okay, and then squared. So 3 squared is 9, 5 squared. 9/25. Okay, -2, 2 and 7/9. -2, 2 and 7/9, you know, most of the way to 3, so it'd be right there. -1, 1 and 2/3, that'd be about right there. Zero 1 is about right there. 1 1 3/5. 3/5 is about 60% up. And then 2 and 9/25. 9/25 is 9/27 would be a third, so it's a little bit more than a third. So 20 and a half and a third. Kind of tough to be perfect, but I pull it off somehow. Anyways, thought I might slide that one by, I guess. See how pretty my curve is? You guys drew some ugly curves, I gotta say.
I bet Richard George practices every night.
No, I just do it for a living.
What's your curveball?
Oh, what is that?
What's your curveball?
It's like just random markers.
Yeah.
Only I can tell what it is.
There.
That's one way.
40 should look kind of like that, shouldn't it? A little bit higher. Yeah. 40 is a lot steeper.
That's easy.
Oh, yeah.